Welcome to another Mr. Paul video. In this segment, we're talking still about 4.2, determining slope and y-intercept, but we're going to dive a little bit more deeper. We're going to talk deeper as far as what these numbers look like, as far as what can we know about the slope and the y-intercept by looking at given equations. So let's remind ourselves a little bit about what we learned yesterday in the previous video. And that was y equals mx plus b. In the previous video, we looked at this m. We know that this is a rate. But when we're talking about a graph, a rate is also called a slope. This b, which we knew as an initial value, when referring to a graph, this is known as the y-intercept. And we're going to quickly find out that just by looking at equations that are in this very specific form, will we quickly be able to identify the slope and the y-intercept, and even more importantly, we can kind of get a small idea of what the graph looks like before having to graph it. So let's just take an example. Example number 1. Y equals 4x plus 3. Y equals 4x plus 3. This relationship, this equation between x and y, is related in a specific way that it matches up with our slope-intercept form. Remember, this is called slope-intercept form. The number that's next to my x, this m, is going to be my slope. So I can think of this 4 as my slope. The number that's all by itself, that's isolated away from the x, is going to be my y-intercept. We're going to eventually start calling this y-int, right? We're going to shorten intercept to int. But for now, this is the y-intercept. So when I ask you, what is a slope? Or what is a y-intercept? I'm going to call it y-int. You can say the number 4, sure. But remember, we're starting to refer to slope as a change in y over a change in x, or a rise over a run. So it's better if we look at this as a fraction, 4 over 1, where the 4 is the rise and the 1 is the run. The y-intercept is going to be the number 3, but it looks like b is equal to 3 or 0, 3. When we say the y-intercept is 3, math has a weird way of saying when graphing, the letter b represents the same thing as y-intercept. So b is equal to 3, or the coordinates 0, 3 are how we can show the y-intercept. Let's look at another example. Example number 2. Let's suppose I have 1/2 x minus 4. 1/2 x minus 4. I should probably be more accurate. Let me change this. Y equals 1/2 x minus 4. Y equals. I wanted to make it look just like this. The y is on one side all by itself. There's a number next to my x, and then I have a number over here all by itself. So the number that's next to my x will be my slope, and the number that's all by itself will be the y-intercept. So when I'm asking what is the slope and what is the y-intercept, the slope is going to be 1/2, where the 1 is the rise and the 2 is the run. The y-intercept will be -4, also known as b is equal to -4 or 0, -4. we can quickly look at the numbers that are associated next to an x or all by itself to give us more information. Even more importantly, we can have a general idea of what this looks like without having to do any work at all. So let's just say I have a very general graph here, and I want to know what this kind of looks like. Well, remember, the slope is whether it's going up or down. If 4 is a positive number, I know that my line has to be positive. It has to look positive. If my intercept is 3, I know it has to cross on the y line at 3. So my line is going to look something like this. Now, this may not be exact, but it gives me an idea of what my line looks like. I know it has a constant rate of 4, and I know it has a y-intercept of 3. This example, give a little general graph there. It has a slope of 1/2. It's not as slopey as this. It's going to be flatter down, but it's going to cross at -4, but it's still positive slope. I know it's going to be going upwards, just not as fast. And then it's going to cross at -4, so somewhere down here. So this graph might look something like this. It's not exact, but I have an idea of what it does. Now, the next two examples are the main takeaway that you can take from this lesson. So even though it's nice to be able to draw little mini sketches from the stuff that we've done before, is it the main point of today? Knowing the different ways that rises and runs, the different ways that your intercepts can look. What is the main takeaway from today? Let's do 2 more examples with just the main takeaway. So let me erase these. And let's do 2 more examples. Example number 3. Let's suppose I have y equals 3x plus 5. If I wanted the main takeaway, I would ask you, what is the slope and what is the y-intercept? The slope, once again, can be found right next to the x. This is my slope. So this is 3. I could also write it 3/1. I'm okay with that. It gives me my rise and my run. Remember, 3 and 3/1 are the same thing. The y-intercept is 5. It will also look like, in a word problem, b equals 5 or 0,5. But at the end of the day, the y-intercept is going to be 5. Our last example. Example number 4. Y equals -3/5 x minus 2. I will ask you, what is the slope and what is the y-intercept? The slope is going to be the number that's right next to the x, meaning this -3/5. So you can say -3/5. It's already a fraction. I know -3 is my rise, and the 5 is my run. The y-intercept is -2. It's this whole thing right there. So it will look like b equals -2 or 0,2. By looking at these equations when they're in this very specific form, also known as slope-intercept form, you can quickly find out 2 pieces of information: the slope and the y-intercept. That will give you an idea whether it's going up or going down and where it would cross the y-axis. That's all for today's video. We will be exploring more about this information. I know it's a lot and it seems a little confusing at first, but keep the faith, stay resilient. Peace.